we're going to do a closer review of comparing fractions.
Okay? Comparing fractions. First thing you have to do is check your denominators. And these are your denominators.
Denominators, okay? This is my example problem. My example problem is going to be
2/3 and 4/5.
okay? Where are my denominators? These are my denominators. We have to check if they are the same, okay? If they are not the same, we have to find a common denominator. If they are the same, we don't have to do it. If they look like this, if these look like this, the denominator is the same, and we would only need to look at the top. Since they are different, the denominator is different, this is what you need to do. So the first thing you had to do was check the denominators. If they are different, you have to do this for step 2.
You have to skip count your denominators. Okay?
So I'm going to get my denominators, which is 3 and 5, and I'm going to skip count. The reason why I skip count the 3 and the 5 is because we need to find one number they both have in common. So we need to find one number they both have in common, okay? So I'm going to skip count right now.
3, 6, 9, 12, and 15, okay? 5, 10, 15, 20, 25.
I only wrote the first 5 numbers for each because if there, usually I can find it. If not, I would have to keep going, okay? So we checked our denominators. We found that they are different. So we need to skip count our denominators to find one thing they both have, okay? So what's one number they both have? They both have, okay, and they both have 15 in common. So I skip count my denominators. I found that they both have 15, okay? Your next step is we gotta multiply to change our denominators, okay? That means we need to change this and this one to 15 because that's what they both have in common. So what do I need to multiply this one by to get the 15? I have to multiply by 1, 2, 3, 4, and 5. So I have to do times 5. But the problem here is I can't just do times 5 on the bottom. I have to do it to the top too. Okay? I had to multiply by 5 because that's how I got 15 for this one. Okay, because 3 times 5 equals 15. If I do times 5 on the bottom, I have to do it to the top. Okay? This one, for the second one, the second fraction. Okay, we have a 5 here. What do I have to multiply this one by to get 15? I have to do 1, 2, and 3. See, I don't have to do 5 times 5 because that's going to be too much. I want to change this to a 15 because that's what they both have in common. So I'm going to do times 3. And if I multiply times 3 in the bottom, I have to do times 3 in the top. Do you see how I'm not using the same number for all the numbers? Why? Because this one needs a different number to multiply to get to 15, and this one needs a different number to multiply to get 15. Okay? So I'm going to erase this really quick. I'm going to find out what my new fractions are. Okay? Remember, we wanted to find a common denominator. They wanted to be the same denominator. They were different before. Now we're multiplying it, so we end up with the same denominator. And this fraction, when I multiply the numbers, changes into 2 times 5 equals 10. 3 times 5 is 15. It changes into 10 15ths. Okay? And this one, okay, I had to multiply by 3. Okay? 4 times 3 equals 12. 5 times 3 equals 15. This one changed into 12 15ths. Now, if you look at the denominator, are they both the same now? Yeah. So now Now that the denominators are both the same, I just look at their numerators. Now I can see which one is bigger, the 10 or the 12, and it'd be the 12, okay? The big thing here is, if they are different denominators, you have to skip count to find a common denominator and then multiply to change these to a common denominator. If you start out with the same denominator, you don't have to worry about doing all of this. But if you have different denominators, you have to do all of this to make them the same. Got it?